Right, welcome back now to part three, erosion. Right, so here's the definition for erosion. So we're removing or we're moving weathered rock material by water, wind, and or glaciers. Right, and we'll start with erosion by water. And usually you can think about it this way, that erosion happens after mass wasting has occurred. Right? So let's look at an example here. Um, if you draw it schematically, you can say, well, all right, we got weathering going on, right? Breaking apart rocks. And then those rock pieces fall off the top of a cliff. That's mass wasting. And then eventually they weather even more to smaller pieces. And they get washed by rain into streams, and from streams into larger rivers. And then eventually these rivers make it to the ocean, and all that dirt that they're bringing, all that weathered material, all that sediment, we call it, goes into the ocean and then settles to the ocean floor in sort of horizontal layers. We call that base level. The ultimate base level on Earth is the bottom of the ocean. Right? So everything ends up at the bottom of the ocean. It's just a matter of time. So there you go. Now, erosion, if you want to say where it starts, so okay, it ends, if you will, erosion ends when the sediment settles at the bottom of the ocean. It starts with a raindrop. Now here's, you see a cool picture of a raindrop impacting soil. Right? And it turns out that raindrops can hit with about 20 miles per hour. That's a that's a fair amount of force, right? If you can think about it, driving in your car going 20 miles per hour and running into a bridge abutment, right? So obviously there's a mechanical force that's generated, and that force breaks apart the soil, and that's pretty clear. And then these smaller soil particles then get washed away by the rain, and especially if we get something called sheet erosion or overland flow. If the rain is intense enough, then the rain cannot infiltrate. It breaks apart the soil and then literally just washes it downhill, and that's something we call soil erosion. Let's look at a few examples here. Here's a perfect example, right? Very often soil erosion is a huge issue in farming areas because the soil is compacted by the machinery, right? And here we have just bare soil exposed. If that gets hit by raindrops, it just starts to wash the little soil particles. All the water, all the dirt, if you collect in these little runnels, in these little rills, and slowly washes down the hill. Or here shown in between, here's corn, and then there's some bare soil, and then there's another row of corn. Of course, this area here very susceptible to raindrops and soil erosion. Another example here, right? We have just bare ground. Maybe this area has recently been reseeded, but it's pretty bare. Raindrops hit it, break apart the soil particles, washes into these little rills, and all ends up in this little gully. Eventually, that water, that weathered material that's being eroded is going down the gully, going into a stream, going into a river, right? So it starts maybe here with some sheet erosion because of high intensity rainfall. It collects in little rills, in little gullies, and then at some point ends up in a river, and then the river, of course, travels towards the ocean. So here's a beautiful shot. This happens to be the Colorado River. So I'm standing in the bottom of the Grand Canyon when I took this picture, and that water you see coming here, and that sediment, that dirt that's in here, is fluvial erosion on its way to the Pacific Ocean. Now, of course, the Colorado River doesn't reach the Pacific Ocean anymore. Rather, it evaporates somewhere in the desert before even reaching the ocean, and that is a whole nother conversation to have, right? So that's fluvial erosion. Now, here's a beautiful example of the Grand Canyon. Now, looking at the Grand Canyon, not from here, I'm at the bottom of the Grand Canyon, right? Basically right down here, if you will, at the bottom of the canyon. And here we're looking at the Grand Canyon as most people see it when you stand on the rim of the Grand Canyon. So what you have is a gigantic hole in the ground. A gigantic hole in the ground that's formed by fluvial erosion, right? Just by the workings of water, of rain, breaking apart little pieces of that rock, washing it down the cliff here, down the slope, a little bit of mass wasting going on, little gullies here, if you can see those. And eventually, all of that material ends up in the Colorado River. And then the Colorado River tries to take it at least to the Pacific Ocean, which would be base level. It would settle to the bottom of the Pacific Ocean to form sedimentary rock. Again, doesn't happen anymore. Whole nother conversation to have. Now, this is what it's supposed to look like, right? So what's supposed to look like, here's your river. This happens to be the Mississippi here. So the Mississippi is coming in and flowing here into the Gulf of Mexico. And here you see that plume of dirt, that plume of sediment that's fluvially eroded off the landscape and being dumped into the Gulf of Mexico here, right? So exactly as you see schematically, here's our river coming, dumping the sediment, and the sediment is settling to the bottom of the ocean, and over hundreds of millions of years turning into sedimentary rock. Everything ends up at the bottom of the ocean. Also very fun is wind erosion, right? So wind erosion is sort of similar to water, right? So wind blows along here, coming here from the left, and then you have loose material, and then it's just a matter of how small the material is and how strong the wind is, whether you get suspension, jumping, or rolling, right? So that the heavy stuff just gets pushed and rolls along the ground. The superfine stuff becomes a dust storm, just gets suspended in the wind, and the material sort of that's a little bit too big but not quite that big is kind of jumping, right? Saltation, we call that. So, fairly straightforward. Dust storm here, wind erosion. We're somewhere in Australia. Wind erosion and dust storms are an issue mainly in arid environments and deserty areas. There's not a lot of vegetation there. There's a lot of loose, fine material there. Wind starts howling, and there you go. You got a dust storm going on. What else do we get? Beautiful landforms are shaped, right? So here we have a beautiful photograph of the Arizona here, these sandstone spires, right? So wind is howling through those, and embedded in the wind, right, is dust and sand or ice crystals in the winter. So now wind becomes incredibly abrasive and can really erode and shape and sculpture rock, because basically what happens is sand blasting or ice blasting. Wind in of itself cannot really erode material, or can certainly erode material, but can't really shape solid rock. But if you have wind, and in that wind is dust, is an abrasive material, or ice crystals, you can get some incredible landforms out of that. Perfect example here, Double Arch in Utah, right? Solid rock, blasted and blasted and blasted over thousands and millions of years by wind and dirt that's in it, carving out these incredible landforms here. Let's look at a few more examples. Bryce Canyon. Right? Bryce Canyon is a combination of fluvial erosion and wind erosion. But you see these incredibly delicate towers of rock. So these are anywhere from like 20 feet to 50 feet tall towers of sedimentary rock, of sandstone, right? Wind howls through here and picks up sand and just blasts the landscape. Bryce Canyon is one of the most beautiful, absolutely gorgeous parts of the country. One of the best national parks to visit because it's fairly accessible. You can visit it, and within a short period of time, hour, 2, 3, you can take easy walks through this incredible landscape and just get a really good feeling for that park. Now, the geek speak term is ventifacts. So here we have a rock. This is a solid rock, right? That has been abraded, sandblasted by wind erosion, right? So this happens to be in Antarctica. So what you have in the polar regions of the world, all these 3 pictures are from Antarctica. You have a lot of wind, you have a lot of sand, you can see all that loose material lying around, and you have ice crystals. And if you've ever been outside in the winter when there's like an ice storm, it hurts, these ice crystals, as they're hitting your face, right? And that's exactly what carves out these rocks. Now, of course, this takes a long time before a solid rock is turned into this particular shape. Nonetheless, that's not a problem. It just takes a while. Vent effects, these are called. Beautiful area here in Death Valley. In fact, this is called Vent Effect Ridge in Death Valley because you see these rocks. Pretty much every rock on this ridge is sculptured, has these grooves, has these holes carved into it by sandblasting, right? So it's windy, there's a lot of loose material. It's just the perfect place. There's no vegetation that would interfere with it. So Vent Effect Ridge. A few more examples here, right? Rocks that have sort of a triangular aerodynamic shape, even some grooves cut into it, right? By wind blasting. So these rocks at some point maybe were rounded or whatever shape they were, but over millions of years, because of wind erosion being blasted by sand, they've turned into vent effects, right? And so you can sort of look at these rocks and sort of think about, well, where are they on Earth? If I want to find this rock, where would I have to go? Or this one, or this one, or this one? Well, here's the answer, right? This rock you can find in Antarctica, this in Death Valley, but those two are actually from Mars. So those are pictures taken by one of the rovers. And of course you would have wind erosion on Mars, right? You have a lot of loose, fine-grained sediment lying on the surface of Mars, and you have wind. So you have wind erosion on Mars, and you can actually even see how the wind is blowing across Mars, and the sand is piling up behind some of those vent effects. It's a cool concept that we can understand the process of vent effect formation by observing it on Earth, and then when we see rocks that look like vent effects on Mars, we can get an idea of what sort of processes are going on Mars, even though we have actually not been there personally. Now, erosion by glaciers is something we'll cover in a lot of detail, so we're only going to sort of get started with it today. So ice glaciers are incredible at carving out the landscape. So, you can look at this backhoe here and sort of think about a glacier as just this backhoe machine that can literally obliterate landscapes and solid rock quite easily. So, for example, right, here's the famous example, Yosemite Valley, right? So all of this at some point, right, used to be solid rock, and then glaciers came through and carved it. That's why this thing is called half dome. Half of the dome, like this half here, is missing. It used to be kind of a domish thing, and then something sort of came through and ripped apart half of it. Well, a glacier ripped up half of half dome. What else we got? More mellow. Right, we're looking at Mount Washington. Here, this is the summit of, well, actually, this is Lion's Head. But, this is Tuckerman Ravine. And so this is a sort of bowl, or some people call it an amphitheater. The scientific name is called a cirque. And this hollow, excuse me, was carved out by a glacier 30,000 years ago. Here's an example from eastern Massachusetts. So we're looking at bedrock here, and you can see this. So this is solid rock, and you can see these parallel grooves. Somehow that's something carved into this solid rock. Well, these grooves are called striations, and they were cut into the rock by a glacier as it came through Massachusetts, if you will, and carved out the landscape, in this case of eastern Massachusetts. Here is a famous photograph from Holliston, Massachusetts, the balancing rocks. So what we got here is a pretty big rock, and then there's a huge rock that's sitting on top of this big rock. So the question, of course, is, well, how did this big rock get on top of this rock, right? What natural process is capable of lifting this gigantic rock? I mean, this is the size of a garage. I mean, this is huge, right? Solid rock. Well, the answer is a glacier, and we'll talk about the details. Lifted up this rock and placed it right onto this rock. So glaciers are incredibly powerful natural forces, right? Here we have the Finger Lakes. So we're looking at Lake Ontario. Here's the city of Rochester, the city of Ithaca, Syracuse, right? And here's all these lakes. These are called the Finger Lakes in upstate New York. And these lakes are all kind of look the same. They're quite a skinny, maybe only a mile or 2 or 3, but they're really, really long. They look like fingers, right? They're tens of miles long, right? Grooves in the landscape carved out by glaciers, filled in with water, and we call those the Finger Lakes. An incredible process when you think about that, that a natural force could carve out these very long, tens of miles long, narrow grooves into the landscape, the Finger Lakes. Now, how does that work? So here's a cool glacier. This is a picture from Iceland, a glacier that's sitting there, and as it's doing its thing, as it's flowing down the hill, the ice is flowing, it's carving out the landscape underneath it. Conceptually, how does that work? We'll look at the details again in a week or two, but let's start conceptually, right? So here's a landscape without a glacier. Here's a river, right? A river cuts into the landscape, gives itself a valley. This might be, let's say this is the Westfield River, right? Flowing down the landscape. So then, over millions of years, the river, the Westfield River or the Connecticut River, cuts itself deeper and deeper into the landscape. That's fluvial erosion, right? Cutting out sediment and bringing that sediment into the ocean and so on and so forth, right? So that's what we call a fluvial landscape, a landscape dissected with rivers and river valleys. Now an ice age happens, this would be stage 3, and these river valleys are now filled with glaciers. And glaciers, very much like water, flow, right, just slower, but as they do so for 10,000, 20,000, 50,000 years, they carve out the landscape, and then once the ice age is over, and the ice age ends and the glaciers disappear, the landscape looks like this, right? So what a glacier does is take a landscape from looking like this to looking like this. That's what glacial erosion does to the landscape. And specifically what that is, glaciers take a river valley, carve it out into what's called a U-shaped valley. So if you have a river valley, you have steep slopes that come together in a V shape, and at the lowest point, that's where the river runs. Well, a glacier makes the size of the valley even steeper, but then you have a very wide valley floor, and then you have another steep slope on the other side. Let's look at a few examples of this. Here is the Delaware River, right? This is the Delaware Water Gap. This is a classic V-shaped valley, right? You have a pretty steep slope here. The river is at the lowest point, and then the slope comes back up to where I'm standing. A V-shaped valley with the Delaware River right at the bottom. Now let's imagine a glacier comes through this for 40,000 years. Here's our glacier, right? Another awesome picture from Iceland. Here's our glacier flowing through, carving out the landscape, 40,000 years, it disappears, and boom, it looks like this, right? You have a very steep slope, but then the valley floor is very wide and open, and then it's very steep on the other side. Looks like a U as opposed to a V. What else we got? Not a beautiful U-shaped valley, right? We are again in the Tetons. We're looking at the Grand Teton here from its backside, and we're looking at this wide valley floor. There's a river in it right now, but this U-shaped valley with the wide floor and the steep slopes on the sides was carved out probably about 15,000, 20,000 years ago when a glacier was flowing down this. Now we go to Glacier National Park. We're looking down a perfectly glacially eroded U-shaped valley, right? And my wife is giving you the U side, right? To show you are looking at a U-shaped valley. Wide floor, actually there's lakes in it, 1, 2, 3 lakes, right? And then steep sides, right? No glacier in there anymore, but not that long ago, probably only about 10,000 years ago, there was a glacier flowing through this, carving out this valley and turning it from a V shape into a U shape. The local example, Franconia Notch, we've looked at this picture before. Cannon Mountain here, this is Interstate 93, right? Steep side, wide floor, steep side. Let's go back, right? This used to look like this, used to be a V-shaped valley. A glacier came through it, and now it looks like a U-shaped valley. Steep sides, wide floor, steep sides. So that's, in general, how glaciers shape out the landscape. All right, let's finish this up. This was part 3, erosion. Very well described on these pages here in your book. This is pretty much in chapter 14 and 15. We've looked at erosion by water, erosion by wind, and erosion by glaciers. Right? And we will look at all of these things in more detail in the upcoming weeks. So that's all. Excuse me. We reviewed weathering. We talked about mass wasting, and then we talked about erosion. So that's it. Have a good weekend, and I'll see you back on Monday.